Okay, we'll talk about Python scope today, which basically means where something is accessed within a Python program. Okay, understanding scope is crucial to avoid bugs and also to improve your code readability and also manage memory very efficiently. Okay, so in this tutorial, we'll cover what is a scope and the four types of scope in Python, which are called LEGB. And also we will cover how variables behave in different scopes. Okay, scope is not specifically tied to variables. Everything in Python has a scope, but we'll use variables for the sake of simplicity. Okay, so what is a scope? Scope refers to the region of code where a variable or a name. What I mean by a name is that a name can be a variable, it can be a class or a function, etc. Okay, so scope refers to the region of code where a name can be accessed and used. Okay, so a region in your code where some variable can be accessed or some function can be accessed and used is called a scope. Okay, let's see the types of scopes that we have in Python. I told you that Python uses the LEGB scope. We have a Python scope called local scope, which is kind of like any variable that is defined inside a function. Okay, and also we have enclosing scope. Enclosing scope means any variable declared inside an outer function, which means if you have an inner function, if you have a nested function, then any variable defined in the parent function is called an enclosing scope variable. And then the G stands for global variable, which means just any variable defined at the top of the file, at the top of the module, at the top of your script that can be accessed by anything in your program is called a global variable or global function or global anything, any name defined. Okay. And also, lastly, the B stands for built-in scope, which is obvious, really. It represents the scope of any built-in function or any built-in stuff in Python. And we're going to see how those can be used, later on. Okay, so let's go over these four types one by one with examples this time, okay? I told you that when it comes to local scope, any variable declared inside a Python function is called a variable that has a local scope because it is only accessible inside that function. That is, I'm emphasizing on this one because it's really crucial you understand it. Okay, so let me define a function. For example, we have a function. This function is called myfunc. So inside this function, if I do something like x equals 10, then maybe I can say print function or just do something that access this variable. Okay, so now I have access to this variable because it is inside this function. It is indented inside the function, so it is only accessible inside the function. That is what I mean by local scope. So if I come here, for example, and I call this function myfunc, okay, and then I run the program, python app.py will run my program. So enter. I see now I'm printing 10, right? Because here is the variable declared 10 and then x is inside, x is the 10. So now it's being printed out when I call the function, right? But after this function call or before the function call or anywhere in this program that is not out inside this inside this function, if I try to access this like I did here, for example, if I copy this line and then I come below the function call and then I paste it, now I want to print x, but x is defined in a local scope, which means it is only accessible inside the function. So this line 6 will throw an error to me, but I'm going to show you. If I run the program again, we're going to see an error because x is not defined. That is exactly what it says. x is not defined because it has a local scope. So now let's move to the second E, okay, the second thing, which is the enclosing scope variables. So for example, let's say inside this function, I have another function, okay? I'm gonna rename this function to something like outer, and then I will define an inner function here because it's inside, okay? And inside here, we can just do the print statement again. We can print and in x, okay? Then here we call the inner function, okay? So let me explain what is happening here after I change the function call to something like outer, so that we will not have any problem here and we don't need this print statement anymore. Okay, so here in this def, in this function, I've defined a function named outer, and it has a variable inside it. Now you can say this variable has a local scope. I agree, because it can be accessed only inside the outer function, right? But also inside the outer function, we have another function which also has a local scope, which means it can only be accessed also inside this outer function. That is why I told you that scope is not tied to variables alone. No, you can have everything has a scope. For example, this function also, it is only callable inside this outer function. You cannot come here and call inner. It wouldn't even make sense because, for example, let me duplicate this line and then I'll move it down. Okay, so if I come here and I call inner, we're gonna have an error because inner is not defined in a global scope. We'll talk about global scope later on, okay? It is defined in a local scope inside this outer function, so it cannot be accessed or modified outside of this outer function, all right? So that is why even if when calling it, we're gonna have to call it inside the outer function. That is what I'm talking about here, okay? Now uh, this X, now we can say it has an enclosing scope because it can also be accessed within the inner functions defined inside the outer function, just like we did right here. So now if I run this program, we're going to see what? We're going to see 10 again because, yeah, the 10 is accessible by the inner function. What happens is that this inner function takes this x and then prints it out when you call it. Had it been we haven't called the function, we will not see any output because it's not doing anything. It's just a function and you didn't call it. So we're gonna have to call it. But when calling it, we're gonna have to call it inside the outer function, okay, because it is only accessible by the outer function. Now when it prints out the x, then the outer function that we call here will accept that x and print it out to us on the terminal, which is why we see 10 here. I hope this is making sense. I really hope that. Okay, so that is the enclosing scope. Now we have L and E. We are halfway through the LEGB acronym. Okay, now, this x can be accessed from the inner function, but it cannot be modified from the inner function. For example, if I try to reassign it, like for example, if I say x, maybe I reassign it to, I don't know, 20. Okay, so if I try to modify this x like this, um, then what happens is that this x is now a new local variable that is only accessible by this inner function. So when you print out the value of it, you print out x, you're going to see 20. And now this x, you can also print out the value of it inside its function, for example, here, because it is at the same level now with this x, so they are inside the same function. This print function is no longer inside the inner function. It's now inside the outer function. So if we print out the value of x, we're gonna see it is we're gonna see 10 and 20 because we're both printing out the inner and the outer x. So we see 10 and 20. So that means we're not modifying the value of this x. But what if you want to modify the value of it, like to print to actually change this x from the outer function inside the inner function to change it to something like this 20? Instead of creating a new variable, you can just do something like nonlocal. This is built into Python. Then break this, and then you modify it. This is the line that triggers the modification, but you're gonna have to explicitly modify it on the second line. All right, on the line beneath that. So if you do this, then you are modifying this x, the value of this x. So I think we are clear. So let's run the program. I'm gonna clear the terminal and then run the program. We should see 20 because we've now modified the value of the x from the outer function. I hope this is making some sense. Okay, so now to the third type of scope in Python, which is called global scope. I'm gonna clear this terminal, hide it, and I'm gonna remove all these. We don't need it anymore. So all right. So now we have a function. This function has a variable inside it, which is x, and this x takes the value 10. Now this x, I told you, is a local variable, and also it can be an enclosing variable if you have another function inside this function. Okay. So a globally scoped variable is just a variable declared at the top of a Python file or Python module. Okay, I can come here and say x equals 20 here. So if I come here and then redeclare this x and say x equals to maybe 50, so what do you expect we will see here? Because this x is in global scope, so it has nothing to do with this x inside the myfunc. So if we say print x here, because this myfunc does not do anything, the x inside it has a local variable scope, so it will not be affected by the modification here, by the modification here. But this x that is set to 20 has a global scope, so it will be modified by the second x that I declare here. So if I print out the x, we should see 50 on the terminal. All right. So global scope just means anything that is declared outside of another function or another class and at the top, because I cannot print out x because before here I cannot do this. I cannot print out x before declaring it. This will throw an error because x is not defined, because Python interpreter executes line by line from the top to bottom. So you have to make it, you have to declare it before you run it, print it or something like that, before you use it. Just okay. But there are times when you'll see people using a keyword in Python called global to modify a global variable from inside a function. Okay, to make a local variable a modifier for a global variable. We're going to see that right now. For example, let's implement a counter. Okay, we can say count, we define a global variable and we set it to 0. So if we define a function, for example, the function we can call it counter. Then here you can type your global keyword, which will make this count global scoped variable accessible inside this function. It can be accessed anyway, but it can also be modified if you add the global keyword here. Okay, so now with this you can do something like count and then plus equals 1. to actually count just one, you know, or something like that. You can do something more meaningful. I'm just trying to demonstrate here, okay? So if we call the counter function, we'll see one. We should see one, hopefully. Okay, we're not printing out anything. Let's print out the count. Print. Okay, so we're printing out the count right now. If we run the program, we should see one because yeah, we incremented the count by one, and we modified the count from inside this function. See what I'm talking about? Okay, so this is doable, but this is not recommended. Okay, you should never do this. Actually, I just showed you because it's good to know, but you should never do this. Okay, this is a very bad practice. So instead of doing this, a better practice is to actually implement the return keyword. So you should remove this. Instead of that, put it inside here, the count variable or argument or parameter in this case, and then you should remove this line. It's no longer needed, and this should be count plus one. So whatever you put inside this should be incremented by one, since that is what our initial function does, right? So, and then inside here we can just say, we can make a variable and store the return value of whatever this counter is inside here. Okay, so what should represent this count? We should put it here. Okay, so what do we want to increment by one? Maybe let's say 5. Okay, so if we put something that's not integer, it's not incrementable, it's not going to be added, the program will crash. So for simplicity, we should just put a number. Okay, so if I print this one, we should see 6. Okay, my bad. I said we should implement a return keyword, the return keyword, and I didn't type it. So if we return it, now we should see, instead of none, well, the return value is now whatever this count is plus 1. So that's it. It's a better practice. Even if it's not the best, it's a better practice than using the global keyword. All right. Okay, so now in our acronym we have a leg. We have LEG. The only thing remaining is the B, which is very easy. I'm gonna clear all of these. Delete and delete. All right. When it comes to the built-in scoped Python objects or built-in scoped Python things, yeah, just say objects, okay? They are functions that we've been using since the start of this tutorial. We have the print function. This is accessible anywhere in any Python program, in any Python file, anywhere, in whatever case, unconditionally, this is accessible. And also we have len, which is used to check the length of an iterable or something like that. We have type, which is another built-in function. We have range, and we have a lot more, like a lot. Okay, so these are some of the built-in functions in Python that have a built-in scope, and these are accessible in any file, anywhere, unconditionally. That means in whatever case. Okay. Okay, I've paused the video and wrote this program just for fun, just to show you, some fun. Okay, this is a counter program that will automatically count from 1 to 5, and in every iteration of this for loop, we have a I, which is a loop variable here, and a range of 1 to 6, which means 1, 2, 3, 4, 5. Okay, we're not including the 6. So in every iteration, this local variable will be incremented by 1, and then it will be printed out, and then it will say count 1, for example, in the first iteration. In the second iteration, it will say count 2 up to 5. And then lastly, when the for loop ended, now in this line, we will print the total counts, which is, 5. Okay, so we'll call the function. So if we run this program, we'll see count 1, 2, 3, 4, 5. Now I've added some spaces here just for clarity when you run the program. Okay, that's it. Let's modify this program a little bit to make it even more, great. Let's add a parameter here. Let's say param, like a parameter, right? So we can remove the range function from here. We'll just say param. So this count now keeps tracks of how many iteration we have run through this, param. Okay, and in every iteration, we will actually increment by 1, which means the number of the values inside the iterable are being counted. So we can add an iterable here. All right, so if we run this program, let's clear this place and run this program. We should hopefully see the number of these items. And now we see count 1, count haha, count through, and a total count of 4. We have 4 items inside. We can remove the print statements here, for example. Here I can remove this print statement, so we should just see the total number of counts of the items inside the params, which makes kind of more sense to me. And we can also put this inside a variable. I'll cut this, put it inside an items variable, and then we just put items here. It should work the same. Yeah, we see 4, so it works. But actually this kind of functionality exists in Python. It is the work of the len function. It is called length. It just returns the length of whatever iterable you give it. So if we give it the length of items here, this is the items variable, right? So if we give this counter the length, the items, we should see the number of it, and the len function also does the same thing. So we should see our custom function and the len function results both. So here we see I forgot to print out this. It returns it. We should print this. Okay, so if we run the program again, let's clear this place. Okay, and then run the program. We see 4 here and then 4 at the edge of the screen right here. Okay, this is the result returned by the len function, and this is our custom function that we defined for counting this stuff. So that's it. Well, I hope you get some value out of this video. If you do, please give me a thumbs up and subscribe to the channel for more videos, for more future videos. Yeah, something like that. See ya.